Hello there, and welcome to the City Beneath Devlog Part 3, where we are building a single-player rogue-lite dungeon crawler in vanilla Minecraft. In this episode, I want to talk about commands, data packs, and what I'm doing to build out the game logic that the dungeon will rely on. The first thing I did was I thought about what actions I wanted to take place in the game. The obvious ones being fighting monsters, finding treasure, solving puzzles, and respawning when you die. But some not so obvious ones were having doors open under certain conditions, like number of kills, or having passageways change randomly each time you start the map. I knew from the start that both redstone logic and a data pack were going to be necessary to facilitate all of the end goals I had in mind. Next, I want to talk about redstone versus data packs. Why not use redstone for everything? Redstone will be used quite a lot in this build, but it's important to point out that it's not perfect for every situation. Redstone is great for in-world interactions like pressing buttons, opening doors, and turning on lights. But if I want to keep track of statistics and scores for the player, the scoreboard command is going to be a much quicker and cleaner way to handle that. And believe me, I did consider building a massive redstone computer to handle scoring, but I wanted this to function in real time, and redstone is pretty slow. So what is a data pack? At a high level, a data pack is a collection of assets that change how the game is played, seen, or heard. This allows you to change any of the artwork or sounds, as well as let you execute commands during gameplay, the same way that a command block does, but on a much larger and more interconnected scale. Next, let's talk about MC functions. An MC function is a text file that can hold several lines of commands. These commands are exactly like what you would type into the command line in-game or into a command block. When configured in different ways, these collections of commands can be executed from within the game and used as a sort of scripting language. What makes MC functions the most powerful is that one MC function can call another by using the /function command. MC function files can also be configured in data packs to run when the game loads, as well as every game tick, which is 20 times a second. That is how we are able to add new functionality to the game in real time. Next, I want to talk about MC lantern files. The most annoying part of writing MC functions to me is that each MC function needs to be a separate file. While code editors do help with all of the tabs, it still felt a little too clunky for me. So I created what I'm calling MC lantern files. MC lantern files are really just big MC function files that have a few special bits of syntax. I also have an MC lantern builder Python script that converts MC lantern files into their separate MC function files. Now that we've talked about the different command mechanisms going on in the background, we can look at some examples of the scripting infrastructure in action. First, let's see what a scripted fight sequence could look like. Note that the end of the path is blocked by a wall of stone. As we approach this barrel, a command executes every tick to check for the player. A specific quantity and type of enemy is spawned in one time behind the player. The player's current kills are at 0. When a specific kill criteria is met, a sound is played. This criteria was to have at least 2 kills. And now the wall of stone at the end of the path is open and the player can continue. Next, let's take a look at how I can programmatically reset the game. We can see here we have a couple of zombies and an item on the ground. This is a state that would follow a player's death after losing a fight. If I then run the command to reset the game, the zombies and the item disappear and are cleaned up for the next run. If I set my total kills to a number that can open the path and then reset the game again, you can see that the path closes as my score is reset. Finally, I want to talk about respawning the player on death and upon logging into the map. When the map first starts, we of course want the player to spawn near the island. If they die before entering the dungeon, we want them to respawn out here as well. And if they leave the map and come back, same thing. Now, if they enter the dungeon and trigger the bridge collapse, then we switch their spawn location to inside of the dungeon. So when they die, they spawn in this room. And if they relog, they spawn in this room. Well, I believe that's it for this video. This one was a little shorter, but I felt it was important to lay out all of the tools and methods I'm using for this map. Next time we will hopefully dive into the builds a bit more and start to craft important areas like the respawn chamber, a market for buying items, and hopefully find the placement for the first level of the dungeon. If you like this video, or devlog content in general, be sure to do the necessary things to not miss the next installments of the series. So long!